For this lesson, we're talking about geometric sequences, okay? And this is going to build off of our lesson on arithmetic sequences, okay? Now, the difference between the two is arithmetic sequences, as those sequences progress, they are growing at a constant rate. For example, right, if it started with 2, an arithmetic sequence might go to 4, 6, 8, where each time a constant number is being added to it, okay? Whereas when we're working with geometric sequence, we're noticing a multiplication pattern. So every time it's moving, it's being multiplied by something, okay? And we're given a formula for this where if we have enough information, we can plug this formula or plug values into this formula to find any term in the sequence, okay? And that formula is A of n equals A times R to the n minus the first power, okay? And what that means, we have it all broken down, right? So this is just saying what term we're testing, right? A of n, right? The first term, that's the first term, so here it would be 3. The first term is the first value that is in your sequence, okay? The common ratio, that is, as the name says, it is the ratio that each change has in common. And we're going to look at those in examples 1 and 2 very specifically to see how do we find a common ratio. Okay? Next is the term number. So notice that those are the same colors. Whatever term you're testing, whether it's the 5th term, the 80th term, the 999th term, whatever term you put into those places. Okay? And then you'll subtract the number 1 from that n term. Okay? So let's look at some problems that we might face. So in numbers 1 and 2 it says find the common ratio. And how you're going to do that is you're going to look and you're going to say, okay, well, you're going to take the second number, 15, over 3. So how did this change? This multiplied by 5, right? And we see that here. 15 divided by 3 is 5. Okay? Well, then we do the same thing here. 75 over 15. Okay? And what that's going to say is, how many times does 15 go into 75? Guess what? It's 5. Okay? It is 5. So, we see a common ratio. Each time we can create that problem and we're going to get the answer of 5. The common ratio is 5. So if we needed to create this geometric sequence and use this formula, we plug in the 5 right there where it says R. Okay? For this one, again, the second number will go on top. So I'm going to get 50 over 100. Okay? And that's equal to 0.5. And that makes sense because 100 to 50, that got divided in half. That was divided by half. And that's what 0.5 equals half. And let's see if that's true for 25 over 50. Yep, 0.5. What about 12.5 over 25? Yep, 0.5. So our common ratio is 0.5. And a general rule of thumb is, notice, it's getting smaller as it goes. So it must be multiplied by something less than the value of 1 if it's getting smaller. If it's getting larger, it needs to be multiplied by something greater than the value of 1. Now, for the 3 and 4, it says determine whether each sequence is arithmetic or geometric. Okay, and remember, I told you, geometric sequences, these ones, the pattern you're going to observe is multiplication. Arithmetic, it's going to be addition. You're going to notice a common change of addition or subtraction, right? Of addition or subtraction. So, looking at number 3, I see that increased by, well, I could say it did multiply by 2. Multiplied by 2. But you added 0.75. So, we could see a couple different patterns happening here. Okay, so it's multiplied by 2, but we added 0.75. We need to see which one of these continues to be true. Okay, so here, we did not multiply by 2 because multiplying by 2 would get us to 3. We added 0.75. For the next one, we added 0.75. So this 2, that's not the correct answer. right? You need to make sure, look at those common ratios. Okay, what's happening each time? Okay, so if you had done the first one, you said, oh, I see it. It's times by 2. It's multiplied by 2. Well, you'd be wrong because that only worked for the first one. You have to make sure it's a true pattern. Okay, it works for each one. Over here, okay. Well, let's look at the common ratios, right? Well, what's happening here? I guess it is pretty easy too. We could write out the common ratios as we did there if we would like. But we're going to go multiplied by 2, or we could say it's 1 is being added. So let's see which one is true. No, we didn't add 1. We multiplied by 2. We multiplied by 2. Okay, so that one is not the right answer. It is being multiplied by 2. So we need to identify what are these. This one is arithmetic because it's adding, right? Okay, so we found the answers to those. For number 5, it says find the first, 4th, and 8th terms of the following sequence. Okay, so we have a to some term equals 2.5 times 2 n to the negative first. So we have most of these things already set up. Sometimes they might just give you this sequence and then expect you to find these different things. Right? So you might need to set up your formula, but as long as you have your list, you say first term, okay. Right? For example, if I was using this, first term would be 100, right? Common ratio we found 0.5, okay, and then the n terms, right? Whatever value you're testing. So find the first, 4th, and 8th terms of the following sequence. Okay, so let's test A, and let's test. We said the first term equals 2.5 times 2. And it's 1 minus 1. Okay, so that's going to get me A of 1 equals 2.5 times 2 to the 0th power. Well, anything to the 0th power is 1, so A of 1 equals 2.5. And this is where we see that rule, that 0 exponent. It's really important that anything to the 0th power equals 1, because otherwise sequences and formulas like this would not work, because this would be to the 0th power. If that equals 0, then it would be 2.5 times 0. So any time would be to the 0th power, it would eliminate the entire problem, right? It would always make it equal to 0. So this is an example where it's really important that anything to the 0th power equals 1. For the 4th term, let's do A of 4 equals 2.5 times 2, and it's 4 minus 1. Well, then we get A of 4 equals 2.5, which would be to the 3rd power. 2 to the 3rd power is 8. And we have 2.5 times by 8. So A of 4 equals, well, that's going to equal 20. Okay? So 20. A of 4 equals 20. For the last one we have the 8th term. Okay. So A of 8 equals 2.5 times by 2, 8 minus 1. A to the 8th power equals 2.5 times by 2 to the 7th power. A of 8 equals 2.5. Well, what does 2 to the 7th power equal? Well, so 2 to the 3rd is 8, to the 4th is 16, to the 5th is 32, to the 6th is 64. That means to the 7th it's going to be 128. 128. Okay. Well, that's getting to the point where maybe I don't want to deal with that mentally, but 2.5, okay, and that's going to get us A of 8 equals 320. So, geometric sequences can be a little tricky if we don't understand how to find the different parts of that sequence or of that formula that we need. So, if you're missing different things like common ratios, we know how to find that. If you're looking for the first term, right? It's very specific. It's the first term, right? If you're looking for the term number, they'll tell you what term to test. So just understand, what's the formula? How do I find the parts of the formula? And then just read the instructions and you should do just fine. Good luck with your lesson.